Welcome back to this how-to guide for our GDS Lab software. In this video, I will be looking to show you how to calibrate one of your transducers. I've just opened a very basic test station which has just got an 8-channel serial data logger, and I'm going to be reading from a single axial displacement transducer. And the first thing I'm going to do is continuously read that transducer. Now it's currently reading minus 260 millivolts. That's because I haven't put any calibration data in this device yet at all. So we've already been through in a previous episode how to set up the device information, but let me just set it up again. I'm going to call this transducer displacement, serial number 1234. The millivolts returned is set because we have a serial pad that always returns millivolts, and I've already put in that this device returns between 5 volts and minus 5 volts, so the full scale is 5000 millivolts. Engineering units we want to use is millimeters, because it's a displacement transducer, and let's read to say 2 decimal places. Upper and safety limit I will ignore for now, and I want to press calibrate, which brings up a little calibration window. You can see in the background we're continuously reading in millivolts, but we want to convert those millivolts into millimeters. So last calibrated, I'm going to click now, and then that puts today's date in, and I'm going to do auto read, which shows the same reading here in our calibration window as it does in our object display. Now I've set up my displacement transducer in a little calibration rig, and I'm only going to do a couple of data points, but I'm going to call this first point 0. So I've got 0 and I've got minus 260 millivolts, and I'm going to say add to the graph. Now I just need to move to the rig, and I'm going to set it to target 1 millimeter. So the next data point will be 1 millimeter. So I fill in the applied value there. The calibration rig has stopped and we're on 1678 millivolts. I'm going to add that, and you will see we start getting a graph building up of our data. So the next value I'm going to target to 2 millimeters. It's on its way there now, and I can choose to add. That's now just stopped, 3600. Add that to the graph, and you can see we've got a nice little table. We've got applied 0, 1 and 2 millimeters. We've got our readings, and we can choose whether or not to use those data points. If we wanted, we could remove one from the calculation. And if we think we're done, and that looks good to me, a very, very simple calibration. R squared value is actually 1 here, so it correlated perfectly. We've got a slope, or what we call a sensitivity. So in this case, it's ended up being 0.00516 millimeters per millivolt. We can apply this, and you can see that the 0.000516 millimeters per millivolt has entered onto our transducer information. Thank you. So hopefully with that information you can understand how to use the calibrate function of GDS Lab.